And I mentioned before filling the DIMMs, and basically what we're talking about here is if I look at my system here, what I have here is some cores with DIMMs and without. What the system will do is it's going to try not to activate cores that don't have local memory. So like this core here, it would try to not to put anything on, and here, and so on. However, it may have to do that, and if it does that, then any memory we use is not called local. If I look at this core here, if I can get my memory out of the DIMMs attached to it, then that is deemed to be local. And that's a much quicker access than for this guy here, who, let's say, he has to go get his memory from over here. We call that near. It's still fast, but it's not as fast as getting it locally. If I now have to go to another node in the 770, for instance, then what I'm talking about is going from here down to here to get my memory, and that has significantly more latency. So that's one of the reasons why you don't get the full bandwidth unless you fill every memory DIMM, and additionally why you want to actually fill all your DIMMs. So basically, to keep out of trouble, all the stuff we talked about, also making sure all the latest performance APARs have been installed. IBM is big on pushing customers to stay current, but there's good reasons for that. As an example, just using firmware, at AL720 064 there was a really nasty hypervisor dispatch bug. At 66 there was a virtual processor folding bug, all of which were fixed in 101. Now the reality is you should be getting onto at least the 730 microcode at this point. You can actually go and look at the firmware history for your server, and you can see, okay, I'm on this firmware. If I go to this firmware level, I notice that all these other things are fixed in between. And the first thing IBM will tell you if you call in with a performance problem, if your firmware is not up to date, they're going to tell you to update it. So you just want to basically take care of that and not put yourself in a position where you're getting told that. And the same applies with AIX. Go look at the documentation on the technology levels. If you go and look at the AIX strength-to-strength PDF that's online, it actually tells you for every technology level pretty much any hypers that were fixed. So it's good to check that so that when you're talking to IBM on a performance problem, things go much smoother. The software stack being current, what I'm talking about here is that when people come to Power 7, if you have back level things like WebSphere, they have some embedded Java code in them. And that embedded Java code, if it's Java 1.4, will absolutely destroy your performance. So making sure that you're bringing across the correctly supported versions of things like WebSphere and applications will actually ensure you get the full performance. Otherwise, if your software stack is not current, let's say it was compiled on a Power 4 and it's really old, what will happen is instructions that it has in it that are no longer in Power 7 will end up getting emulated. And if the alignment has changed for the word boundary, they will also go through alignments. And emulations and alignments are very expensive. There's a command called emstat that is very good for finding those. In terms of compilers, having them be current, basically that's because if you're using an old compiler, it's not going to compile it with all of the options for multi-threading, etc. for Power 7. And to get MPIO, you need to run the correct multipath software. You really want to look at, if you're running IBM, then run your STD or STD PCM or RDAC. If you're running EMC run PowerPath, if you're running the HTS run, whatever theirs is, those multipath drivers, which also should be up to date, will make sure that you get the best performance that you can out of your multipath I/O. Tunables, I've got some samples at the end of this of what that I usually start with. Reading the READMEs, and I have that in red because there are a lot of people who were not reading the READMEs for firmware because they'd done a bunch of updates. They weren't reading READMEs for update. And what we found was when HMC 773 came out and firmware 773, there was a big red mark in there that said you must upgrade your HMC before you upgrade your server. Otherwise, if you upgrade the server to 773 first and then do a live partition mobility action, you will corrupt your server's processor. And it was clearly spelled out in the README, but nobody read them. So it is highly recommended that before you do anything, you read the READMEs. And normally I do things where I will update my HMC first, then I will do any firmware, and then I'll do my VIO server upgrades and then my AIX upgrades. but I still check, and you can do that using the fixed level recommendation tool to make sure that everything that I'm doing is supported and fits into the matrix of what goes with what. A couple of last points, collecting baselines. I'm going to talk about performance baselines. These are really critical. You don't know, how do you know if you have a problem if you don't know what normal is? And how do you determine what the problem is if you don't know what normal is? And this is where I see a lot of people fall down. They don't take baselines, and then they do something, they make a change, and once you make a change, from then on, everything that goes wrong is your fault. It's really important that you have that baseline. There's a couple of different ways you can do baselines, and we're going to talk about those. And the other thing is documentation, not just on the apps and everything, but you should have a SysPlan if you can get one. The new HMC scanner tool is really cool. It actually gives you a spreadsheet of all of your LPARs and how they're laid out and everything, so you can rebuild it from scratch if you have to. And it takes like 3 minutes to run. And then this is motherhood and apple pie. But as I say at the bottom, it might look like common sense, but in an emergency, that's the first thing that goes out the window. So when you're making changes, or even when you're looking at a performance problem, you have to first be able to describe the problem. I've read PMRs that people have opened, and I was working with them when they first had the problem, and I'm looking at the PMR going, I have no idea what problem they're talking about, but it does not match what we're seeing. So you have to be able to describe the problem, take a baseline. If you can recreate it while you're getting the diagnostic data, that's great. Document your changes. What do you expect to have happen? And don't make a whole bunch of changes at a time that don't naturally go together. The comments I have about remembering one small change that only you know about can cause significant problems. I was actually in a situation like that many years ago where someone made a small change, didn't think it was relevant, and it turned out that that was the change that kept their server down for 3 days. I hate change control, as does most people, but some kind of change control keeps you out of trouble. And it's an iterative process, hence the comment at the end, if the problem isn't fixed, go back to step 3 and go through all these loops again. Alright, so these are the sample performance tuning parameters that I was talking about with the new values that everything should be set to. I'm not going to go into these in detail. There's a AIX performance tuning session, and I'll probably run that again in the new year, that goes into all of these. They're just in here really so that you have starting points. We spent about 40 minutes talking about how to avoid a performance problem, some of the things to think about when you're designing and architecting. Now we're going to talk about, okay, I've got one. What do I do? And the first thing is don't panic. Most people, 4 vice presidents come into the room, there's a serious problem, and everybody's running around like headless chickens. You don't want to be in that situation. You really want to take a deep breath and go, okay, I need to think about this for a couple of seconds. And then you have to have some rules of the road. And people laughed about the first one, but, we all get dragged onto bridge calls and everybody wants updates every 3 minutes. You have to be nice about it, but getting rid of all the unnecessary people and having someone take the bridge call that comes and checks with you every 15 minutes is a really good thing to have as your strategy. Because, let's face it, you can't think and debug a problem when you've got a whole bunch of people looking over your shoulder going, what are you doing, what are you doing? You can either fix it or you can talk to them. Very few people can do both well. That's something you should talk with management about how you actually work on problems so there's a plan in place that everybody knows. And I realize that that's a nice to have, but it definitely makes life a lot easier. Having a baseline to compare to, and this goes back to my comment, how do you know what's bad when you don't know what's normal? And of course, whenever you make changes, you should take new baselines. But don't make so many changes it's impossible to figure out what broke it. Sometimes you only get 1 or 2 maintenance windows a year for infrastructure type changes. So everybody tries to cram everything in at once. So you've got the storage people making changes, the database people making changes, you're trying to upgrade AIX, and while you're at it, you're doing some LPM moves, and the network guy comes in and decides to change the network. You really have to plan these out, and you really have to sit there and go, okay, how many things do I want to change at a time, knowing that I won't know till tomorrow when the users come in if there's a problem. So I can't tell you how many times I've seen it where they've tried to cram too many things in and taken a significant outage, which is why there's a good argument to be made for having shorter but more infrastructure outages and taking advantage of technologies like live partition mobility so that they're not outages, they're actually planned moves. So I would try to build that into your strategy. Good documentation, like I said, the SysPlan or the HMC scanner, which by the way, the HMC scanner now works for both the HMC and Flex Manager. So you can point it at both of them and get them documented. So then, of course, the first step is gathering information. You need a clear description of the problem, what happened, what is the problem, any error messages. Without a clear description of the problem, you're not going to be able to report it, you're not going to be able to debug it. That is probably the hardest thing to get. I kind of laugh about this one. I'll Google before asking dumb questions. So many times an APAR or a problem is actually, or someone else has already had it. So it's always wise to Google it and see if somebody else has had the problem, if it's a known problem, and if it's an easy fix. And I've solved problems in areas that I've never even worked before just by looking at Google, looking at the description of the problem, and seeing if it makes sense and matches anything that we were talking about. None of us like calling and talking to level 1 and before we get escalated, so you can probably save yourself a call sometimes by doing this. So I mentioned baselines. Taking a baseline, it doesn't matter what you use, it just has to be consistent and repeatable and meaningful. I use a combination of the latest Perf PMR for the version that I'm running. I'll download that. I'll use Nmon, and I have a script that I gather some other things. And I'll run that whenever I make changes before and after, or whenever I have a problem. The Perf PMR you've got to run because that's what IBM's going to ask you for. And by the way, if you have a Perf PMR from before, and now you've got a problem and you run a Perf PMR for them, that makes it much easier for them to debug your problem because they know what it looked like, a week ago and what it now looks like, and they can compare that data and go, well, something changed in this area because of what I'm seeing in this file, so now we can narrow down. So it's actually a really good strategy to take those regularly. On AIX5.3, at TL9, Topaz included Nmon, so you could run Nmon Topaz, but I still find that it doesn't behave as well with shared processor stuff, so I still download Nmon for that. In version 6 and 7, I use the one that comes with the system. So you see the crontrab entry, I basically run Nmon 724 anyway. This is not granular enough. If you look at the bottom one, I'm taking a snap every 150 seconds. That's not granular enough for debugging a problem, but it will give you some historical data that you can use for capacity and performance and give you an idea that, well, wait a minute, every day at 5 o'clock I'm seeing this particular spike and my phone's ringing off the hook at 5 o'clock, so I'll go check into what that is. The flags that you see that I have on here, I think the tilde is the one that gets you the new fiber adapter stats, but basically this is going to get you large pages, asynchronous I/O, it'll get you the top processes, and it will get you the fiber adapter statistics, all of which you want. A lot of people don't use those, haven't been using those flags. I use those flags all the time now.